when we have the chemical control. It's by corrosion inhibitors. I will talk about corrosion inhibitors. However, there are pH controllers. So there are substances that add into the solution to increase the pH. When we increase the pH, we are basically reducing protons, and then the corrosion is reduced as well. There are scavengers. Scavengers are chemicals that are added into the solution to reduce the corrosive species. That, for example, if we have oxygen in the solution, we can add oxygen scavenger, and we can control the oxygen content and reduce corrosion. The same for H2S. We have H2S scavengers that we can utilize to reduce corrosion due to H2S. I will talk about corrosion inhibitors like surfactants, that they have the capacity to go to the surface and absorb to the surface. There is one typical example, that is the soap, the hand soap, the ones that you use to wash your hands. This is a surfactant. What is happening is you take the soap, and then basically when you start to froth your hands, you are adding air into the surface, into the interface soap water. You have now the air. Then it starts to foaming. This is a typical surfactant. It starts to foam because you have the tail and the head, and I will explain that. Usually, they are water soluble and oil soluble. The water soluble is weaker than the oil soluble to have good adherence in the surface. And the oil soluble is stronger in the adherence. One way to measure, or the way to measure adherence, is by measuring the energy of absorption. As a rule of thumb, 25 kilojoules per mole or minus 25 kilojoules per mole of absorption, of energy of absorption, means that you are in the chemisorption. So it's usually those compounds. If you are higher than minus 25 kilojoules per mole, so it means like if you have minus 10 kilojoules per mole, you are in the physisorption, and then you are more in this other area. This is how the molecules are looks. Well, it doesn't look like that, but this is the design. So they have usually a pendant like this, and then they have a chain. So the R is a chain there. So we have the amine, imidazoline, the acids, fatty acids, not the short length of fatty acid like acetic acid or formic acid. This is more like into the butyric or propionic acid, and higher, that they have R chains or 13 or larger. Amide, there's another one, and then they have the quaternary ammonium salts. This is I will use this example just to put it in perspective. This is the hydrophilic head. So when I talk about the hands, when you wash your hands, this head, it tends to be in the water interface. When you wash your hands, you take water, and then you start to move to froth. Then this phase tends to be in the water phase, and the tail is looking the gas phase, because the tail doesn't like water. It's the hydrophobic tail, so it doesn't like water. Then it goes to the gas phase, and then it starts to foaming. It's exactly the same is happening in the stuff. So I will, just for the purpose of explanation, to make this type of simple diagram, Mickey Mouse diagram, to exemplify or to put the example.